Hello, mathematicians. Okay, here you are working on your practice finding same area with different perimeter on page 725 and 726. Now, as you were working on this, you could have gone through the example to see how to solve the problems. We're going to jump into the answers in number 1 and see how you did. Now remember, if you've made a mistake, go ahead and stop and fix it. And if you did got it correct, then pat yourself on the back for a good job. Okay, so in number 1, they asked you to look at both rectangles on the right and notice that they both have an area of 12 units, square units, because 2 times 6 is 12 and 3 times 4 is also 12. They've even put the information in a table over here for you. Our length is 6, our width is 2, 6 times 2 is 12 square units. Now, what they wanted you to do was find the perimeter. So notice over here on the side, I had to show my work. I went 2 plus 6 plus 2 plus 6, and I added them together to get 16. So I came over here and wrote that my 6 by 2 had a perimeter of 16. I did the same thing for my 4 by 3. I have a side of 3 plus 4 plus 3 plus 4, and when I add it together, I get 14. This is how you use a table to help keep your numbers organized. Okay, number 2, draw 2 different rectangles that have an area of 10 square units. So in order to draw my rectangles, I first did a 1 by 10, right? I had a width of 1 and a length of 10. And over here, I found out the perimeter. I added all 4 sides. 1 plus 10 plus 1 plus 10 is 22. So this one has a perimeter of 22. Now, our second rectangle that I wanted to draw also has to have 10 square units. And I know that 10 is the same thing as 2 times 5. So I have a width of 2 and I have a length of 5. 2 plus 5 plus 2 plus 5 is 14. Now what they wanted to do is fill in the information. My first rectangle, notice here, I have a length of 10 and I have a width of 1 and my perimeter was 22. My second rectangle had a length of 5, a width of 2, and if I counted all the sides together, I got 14. Okay, on the back side. Number 3. Simone had 16 square inch tiles. She glues all of them on a cardboard to make 2 different rectangles, each with the same area. What are the side lengths of 2 rectangles she can make? Well, I wanted to show you that there's at least 3. So if you have 2 of the 3 that I have here, then you're doing a good job. Okay, so number 16. I have a 1 by 16. I could have drawn a 2 by 8, and I could have drawn a 4 by 4. So I did that over here. With an area of 16, I could have a square with 4 by 4. I also made a rectangle with 8 by 2. And I made a long, skinny rectangle of 16 by 1. Now remember, if we turn them all on their side, we could have done 3 more. So you could have drawn them all vertically or you could have drawn them horizontally. But there were 3 different ways to draw rectangles. Okay, in number 4, Simone wants to glue colored string around the edges of the 2 rectangles she made in problem 3. What is the total length of string she needs for each rectangle? Show your work. Okay, so now that we've made our rectangles, what is the perimeter? So notice that for this rectangle, I put all my information right here. Since this is a square, I added 4 plus 4 plus 4 plus 4 to find a perimeter of 16 units. Oh no, they used inches, right? Inches, not units. Then for my second one, notice I had a length of 8 and a width of 2. I used that information and found a perimeter of 20 inches. Then I took my third one that I made and I counted the perimeter again. I used the 16, I used the 1, the 16 across the top, and then the 1. And when I add that together, I get 34 inches. So let's go ahead and take a look. What is the total length of string she needs for each rectangle? Ooh, which one would use the layer? That's right, our 4x4 uses the least amount of string. Which rectangle uses the most string? The 34 inches, our long skinny one. That's interesting. Okay, number 5. Enrique draws the rectangle at the right. He's got a 5x4. Draw another rectangle with the same area but a different perimeter. Okay, so what do I have here? This is an area of 5, right? Oh, no, sorry, not 5. 5 times 4. Area of 5 times 4 is 20. So my entire area is 20. Now I have to draw another rectangle with the same area. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, but I have to have a different perimeter. Oh no, what does this have? Does this have the same perimeter? Let's see. 5 plus 4 plus 5 plus 4. My perimeter, what's my perimeter? Can you add that up? It is 18. Now notice I drew a rectangle here. It has the same area. It has an area of 20. But what do you notice about its perimeter? 5, 4, 5, 4. Did I make the same rectangle? I did. So I noticed that when I go to count my perimeter, it is the same. So I can't use this one. So now let's go ahead and erase and see what else we can do. Sometimes that happens. I use a rectangle and I notice, oop, that doesn't fit. Okay, so I started to make a table over here for myself to check this out. Since I have a 1x20, I could make a 1x20. What else goes into 20? 2 times 10 and 4 times 5. I can't use this one because that's the one they used and that has the same perimeter. So I can draw one of these two. Let's go ahead and do the 2x10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to have to end here. Right, that's the length of 10. And then how wide? 2. Okay, now, does this have an area of 20? It has 2 and 10, right? 2 times 10 is 20. Now, what is the perimeter of this one? Let's see if I did this one right. Okay, my perimeter is 10 plus my 2 plus 10 plus 2. 10 plus 2 is 12. 10 plus 2 is 12. They come together as 24. Yay! Do I have a perimeter that's different? I do. So now I have 2 rectangles with an area of 20, but their perimeters are different. So let's go ahead and answer the question. Which rectangle has the greater perimeter? Which one's greater? The 18 or the 24? The 24 is larger. So our new rectangle has a larger or greater perimeter. Okay, and that is it for session 3. I'll see you next time for session 4.